Okay, so my name is Bilal, and today we'll be solving additional mathematics session May June 2022, paper 1 and variant 1 2, which is of 2 hours. Now, before starting, I would like to make an announcement, and that is please do make sure to like, share, and subscribe our channel. Now, moving on, we have this question number 1. The diagram shows the graph of y is equals to a sine bx plus c, where a, b, and c are integers for 180 till negative 180 till 180 degrees. Find the values of a, b, and c. Now, first of all, we need to identify from where it starts. So it basically starts from here. We can take this as a point of start. So this is the line where it starts from. So we can write this as negative 3. We get our c from here. So our c is negative 3. Our a is basically our amplitude. Now this is 1, 2, 3, 4, and then 5. So we have our amplitude as 5. Now we need to identify the period. What is the period? Now you can clearly see um, that in 180 degrees there are two waves altogether. Here it is 1, this is 1, and then this is 2. Normally we have 360. Normally we have a single wave in 360 degrees. So in 360 degrees we will have four waves, which means the period is basically 4. So we can write this as 5 sine 4x minus 3. So this is our answer finally. Now moving on, we have question 2. I'm sorry. Which is given that x is equals to sec square theta, y plus 2 is equals to cot square theta. Now it needs y in terms of x. So we need to, let's simplify this a little bit. So this would be y, sorry, cot square theta negative 2. This would be equal to y. Let's rearrange this a little bit. So this would be 1 over cos square theta equals to 1, and cos square theta would be 1 over x simply. So we can write this as y is equals to cot square theta can be written as cos square theta over sine square theta negative 2, and this sine square we have this cos square theta over here, and this sine square theta can be written as 1 minus cos square theta as our identity, which was our identity. So let's write it down. This would be 1 over x, 1 minus 1 over x, and then negative 2. So by solving this, we get it as this would be 1 over x divided by x minus 1 over x. This x and x would be cancelled out, and then this is negative 2. So this would be 1 over x minus 1 and then negative 2 as our y. So we have our y as this. So moving on, we have question 3, where variables x and y are such that when LG 2y plus 1 is plotted against x square, a straight line graph passing through the points 1, 1 and 2, 5 is obtained. This means LG 2y plus 1 is our y. M has to be found out, and our x is basically x square. This can be written as x square, and this is our x, this is our m. Let's write it small m here, and then this is plus c, so this would be our c. Now let's solve this a little bit to get our gradient. We will use these 2 points. So this would be 5 minus 1, that is y2 minus y1 over x2 minus x1. This would be 5 minus 1, that is 4, and that would be 2 minus 1, that is 1. So we have our gradient as 4. We can calculate our c by using y minus y1 and m x minus x1. So this would be y minus 1 equal to 4 x minus 1, and we can write this as 4x. This would be minus 4 and then plus 1, so this would be negative 3. So we have our equation. All right. So we can write this equation. We can substitute the equation as Lg 2y plus 1. 4 is our gradient, x square is our x, and then negative 3 is our c. All right. So we need y in terms of x. So if we remove this Lg, this whole will go in tens power. So this would be 10 4x squared minus 3 2y plus 1. Then this one will be negative on the right hand side, and then 2 would be divided. So this would finally be written as 4x squared minus 3 minus 1 over 2. So this is our final answer. Now we have find the value of y when x equals to root 3 upon 2. We can simply substitute root 3 upon 2 over here. So let's substitute it. We'll get it as 10 root 3 whole squared, then negative 3 in our power, then this is minus 1, and then upon 2. Since it is squared, this square and this square would be cancelled out. This would be 3. 3 minus 3 is basically 10 into 3 minus 3 is basically 1. This would be 10 powered 0, and 10 powered 0 is 1. 1 minus 1 is 0, so this would be 0. So this is our final answer. Now here it is given find the value of y when find the value of x when y is equals to 2. We can simply substitute in our original equation, that is Lg 2y plus 1 equals to 4x squared negative 3. This would be Lg 5 plus 3 over 4, and then whole squared. This 3 will go over there, this 4 would be divided, and we get our final answer as something like this. We can solve this and we'll get our answer as plus minus 0.962. Sorry, this is our final answer. Since it's a square root, this would be plus minus, right? Moving on, we have question 4. Find the unit vector in the same direction as this. We have the direction, we need the magnitude only. So this would be 15 squared and then 8 squared. This would give us our answer as 17. So we can write this as simply negative 15, 8, and then 1 over 17. So this is our final answer. Given that 2a plus 4b minus 12 is equals to 4 into b minus a over and a plus 2b, find the value of a and b. So it needs a value of a and b. Let's just solve this first. This would be 2a plus 4b minus 12, and below we have negative 5 plus 3 would be negative 2, I guess. Yes, negative 2. And in the next line we have 4b minus 4a, and here we have 4a plus 8b. We have two equations. We can solve this, or you can just cancel it out. This 2a will go over there, so this would be negative 6a, negative 12. A will be 2. We can substitute it over here. This would be negative 2. 4 into 2 plus 8b. Then this would go over there, so this would be 8 and negative 2 would be negative 10, and then this 8 would be divided. So we have our final answer of b as negative 5 over 4. So we have our a and b here. Now moving on, we have question 5, where the first three terms in ascending powers of x in the expansion of this can be written in the form of this, where p and q are constant. Find the values of p and q. It's an 8-marked question. This would be pretty difficult question, or I can say a lengthy question. Let's start with this first. We have 2 minus 3x powered whole cube. It needs ascending powers of x, and this needs to be in till x squared. So we keep it till x squared, or we can directly complete it as well. So this would be 2 powered 3. 2 powered 3 is basically 8, and then it goes 3c1. 3c1 is 3. Then 2 power 2 is 4, and then this 3x is simply this. And since it's negative, so the second term would be negative, third term would be positive, and then the next one would be negative. And then 3c2 is again 3. Then this would be 2 powered 1, and then 3x powered 2, right? And then we'll have 3x powered whole cube. Now we won't be using this since we don't need an x cube equation. Now let's solve this. This would be 1 plus x upon 6 whole power 12. So we have this as 1 plus 12. C1 is 12 basically. And then x over 6. We won't be writing 1 powered anything because 1 to the power anything is 1 simply. So this would be 12, and then 12c2 x squared over 36, because this x over 6 is squared, so this would be x squared over 36, and then these two would be multiplied. So if we need this 8, this one will be multiplied by 8, so this would be 8. Now we need the x terms. So this one can be multiplied to this, and then this term can be multiplied to this. So this would be 3 into 4 is 12, 12 into 3 is 36, so this would be negative 36x. And this can be cancelled out, so this would be 2x multiplied by 8. 2x multiplied by 8 would be 16x plus 16x. So we have our x. Now we need our x square. So x square can be simply multiplied by this can be multiplied by this, and this can be multiplied by this, right? This x square term can be multiplied by non-x term. This x term can be multiplied by simple x term to get x square, and then this non-x term can be multiplied to this x square term to get our x square, right? So this would look something like this is 36x, and then 2x, this would be 72x squared, right? And then this would be 3 squared is 20. 3 squared is basically 9. 9 into 3 is 27. 27 into 2 is 54. So this is 54x squared. Our next would be this one. This was left. So 12c2 and divided by 36 and then multiplied by 8, we get our final answer as 44 over 3x squared. So finally when we solve this by using our calculator, these coefficients will be added up. So we get our answers as, sorry, this would be negative 72. I made a mistake over here. This would be negative 72 because we are multiplying this by positive and negative. So this would be negative. We get our final answer as 8, negative 20x, negative 10 over 3 x square. So this is our Q and this is our P, right? Moving on to question 6, we have the polynomial P of x equals to 6x cube plus ax square plus 6x plus b, where a and b are integers, is divisible by 2x minus 1. When P of x is divided by x minus 2, the remainder is 120. So let's make the two equations. So this would be 2x minus 1 equals to 0. Our x would be 1 over 2 and the remainder would be 0 since it's divisible. So let's plug it in. So this would be 6 1 over 2 whole cubed plus a 1 over 2 whole squared plus 6 1 over 2 plus b equals to 0 since it's divisible. So this would look something like, can we take 6 as common? Can we take 6 as, let's solve this first. So this would be 6 upon 8, and then this would be a upon 4. This would be 3, and then this would be plus b equals to 0. Simplify this. Let's simplify this a little bit. So this would be 3 and 4. We can multiply whole equation by 4 to get our answer as 3 plus a plus 12 plus 4b equals to 0. Let's solve this a little bit. So this would be a plus 4b equals to negative 15 as our first equation. Now let's move to our second equation where we are supposed to be dividing it by x minus 2. So this would be x equals to 2 and our remainder is 120 as stated in the question. So let's plug 2 in it. 2 in the equation, so this would be a plus 2 a into 2 squared plus 6 into 2 plus b equals to 120. And then we solve this. So this, after solving this, we get 48 plus 4a plus 12 plus b equals to 120. This would be 60. This 60 would go over there. So this would be 4a plus b equals to 60. We can multiply this by negative 4 so that we can cancel this 4b and this 4b. So this would be a minus 16b. This would be minus 15. A minus 15a. So this would be minus 16a. So this would be minus 15a. And this would be negative 240, and then this is negative 15. So they will be getting it as negative 255. Negative and negative would be cancelled out. We get our a as 17, and we can plug it over here. So this would be negative 15 and negative 17 is negative 32. So 4b would be negative 32. 4 can be divided, and then we can get our answer as b as negative 8. So we have our a and b. Now part b says, hence write down the remainder when p of x is divided by x, which means x is equals to 0. So when we plug in x equals to 0, we simply get b. This would be 0, this would be 0, this would be 0. So we have our b as negative 8. So our answer would be, our remainder would be negative 8. Find the value of p double differentiated and then 0. So we can solve this by taking the differentiation 2 times. So we have our equation as 6x cubed plus 17 x square, then plus 6x, then negative 8 is equals to 0. Let's keep it. This is our p of x basically, right? So this is 17 and then this is negative 8. All right, so we have written the equation correctly. Now we need to differentiate it. For differentiation, this power will be multiplied and then subtracted by 1. So this would be 18x squared. This would be multiplied. So this would be 34x, and then this would be 6. We need to differentiate it again. So this power would be multiplied. So this would be 36x. Then this would be 34. And we need to plug in 0 in the x part. So this would be 36 into 0 plus 34. So we get our p double differentiated and then 0 plugged in as 34, sorry. So this is the right answer. Now moving on, we have question 7, which states, show that 2 over 2x minus 3 minus x plus 1 plus x plus 1 whole cube can be written as something like this, right? Now let's quickly take the LCM. Here it needs x minus 1 whole squared. Here 2x plus 3 is required and x minus 1 is required, right? And here we require 2x plus 3, right? So let's quickly simplify it. X minus 1 whole squared is basically x squared plus 2x, x squared minus 2x plus 1. We'll multiply this by 2 and we'll be directly writing this. So this would be 2x squared negative 4x plus 2, and then this would be multiplied. So this 2x and 2x and x would be multiplied. So this would be 2x squared. This would be negative since it's multiplied by the negative value. This would be negative. And we have 3x and negative 2x. So 3 plus 3x and negative 2x we get as positive x, and then this would be multiplied by negative. So this would be negative x. And then this would be negative 3 and negative 3 would be multiplied by negative 1. So this would be positive 3. So we get our answer. Now we have this. So this would be 2x plus 3. Now we can cancel some things, or let's just go about this. Let's check it. So this would be cancelled out, and we have our answers as simply, this is negative 5x and then positive 2x. So this would be negative 3x, and we have our LCM as x minus 1 whole squared and 2x plus 3. So this would be negative 3x since it's negative 5x, and then plus 2x. So this would be negative 3x. We have 2, we have 3 and then 3. So this would be 8. Hence, we have proved it, right? Now, moving on, we have our part B as find with the limits a and 2 this dx where a is greater than 2, giving your answer in the form c plus l and d, where c and d are functions. A has to be greater than 2 since it's the upper limit, right? Let's just so we know this can be written as simply this, right? So let's write it like this. So this would be a 2 over 2x plus 3 negative x minus 1 positive x minus 1 power minus 2. So I have written all this here, right? I have just taken this to the upper side, right? So let's solve this. This is basically function in the denominator. We need to have the differentiation. In the numerator, we have the differentiation, so we can write it as ln 2a 2x plus 3. Then similar case, we have our differentiation, so this would be ln x minus 1, sorry, and here we have negative, and this would be negative, this power would be added, so this would be negative 1, and then negative 1 would be in the denominator, so this would be negative x minus 1 powered 1, and then we need to apply the limits. So we have the limits of a and 2. Let's just apply the limit of a first, so this would be ln 2a plus 3, then negative ln a minus 1, then negative a minus 1. So we have this as upper limit. Now we'll move on to our lower limit. Our lower limit is ln 2 into 2 is 4, 4 plus 3 is 7. And then we have 2 minus 1 as ln 1, so ln 1 is basically 0. And this would be minus 1, right? So we can write this as, let's just write each and everything all together. So this is positive, this is negative, and this is again negative. So this would be ln 2a plus 3 in our numerator, and this 7 will be in denominator, and this would be multiplied by my a minus 1 this, and we have minus a 1 over a minus 1 and this positive 1, right? So we can write this as, we can take the LCM, so this would be a minus 1 is multiplied, so we get it as a minus 2 over a minus 1, and this is same ln 2a plus 3 over 7 into a minus 1. So this is it. We have our answer. Now moving on, we have our question 8 of what can I say, combination, permutation and combination. So this is basically a team of 6 people is to be chosen from 10 people. 2 of the people are sister who must not be separated. Find the number of different ways that can be found. So they must not be separated. This means they need to be together, but they can be in the team. If they, we have to identify if they are in the team or out of the team, right? Because these are the only 2 ways they cannot be separated. So when we have those 2 sisters, we are left with 8 people and we need 4 more people. So this would be 8c4, and this is basically 70. Now, if we have without sisters, let me write it down. So 2 people are not here. So this would, we have to select it from 8 people, and we have to select all the 6 people. So this would be 8c6, and this 8c6 is basically 28. We add both of them, so we get it as 98. So this is our final answer. Now moving on to part B, this is of permutation. This would be a 6-character password is to be chosen from the following characters. No characters may be used more than once. Find the number of different passwords that may be chosen if there are no restrictions. Alright, so a 6-digit password has to be chosen. So this would be 9p6, since it can be anything, right? Or you can simply write it as, this would be 9, this would be 7, this would be 6, this would be 5, and this would be 4. These are the 6 digits. We'll have 9 possibilities. We have 7, 8, then 7, then 6, and then 5, and then 4 possibilities. So we get our answer as 60480, right? Moving on, we have the password starts with two letters and end with two digits, right? So it has to start with the two letters and two digits. So we have three possibilities over here and two possibilities over here. Since it starts with the two letters, right? We have three letters over here, right? And it ends with two digits, and we have three digits over here. So we have three possibilities over here and two possibilities over here. Now we are left with the only two possibilities. We have already chosen four, so we are left with the other five, and then the one is chosen from here, so this would be four. Now we can multiply all of them, so we get our final answer. Now we get our final answer as say this would be 6, this would be 20, this would be 6, so this would be 720. So this is our final answer. Now moving on to question 9, we have the normal to the curve. This whole equation is given at the point A on the curve where x equals to 0 meets the x-axis at point B. Point C has coordinates 0, 3 ln 2. Find the gradient of the line BC in terms of ln 2. It needs in terms of ln 2. So we need to make sure that the answer is in terms of ln 2, right? So let's see the space we have. Oh, okay. So we have only a single page. Okay. So the normal to the curve at the point A where x equals to 0. Let's first calculate the y when x equals to 0. So when x equals to 0, this is ln 2, and then this is 0 plus 1 is 1. So this would be y is equals to ln 2 when our x is 0, right? Now we need to calculate the differentiation to get the gradient to the normal. First we'll get the gradient to the tangent, then we'll take the inverse reciprocal to get our normal's gradient. So we can take the gradient by using the quotient law of differentiation, which states that v u dash minus v, when we take the differentiation of two polynomials when they are divided. So this is simply written as the v polynomial, differentiation of polynomial u, and then polynomials differentiation, v's polynomial differentiation, and then v squared. And then we can assume this as u and this is v. So let's write it down. We have our v as x plus 1. We have our u dash as this is ln 3x square plus 2. So the differentiation comes in the numerator. So this would be 6x, and the original function comes in the denominator. Sorry. So this would be something like this, and then minus ln 3x squared plus 2. This would be multiplied by 1 since this differentiation would be 1, and then we have x plus 1 whole squared, right? Now since x equals to 0, we can plug in x equals to 0 over here. So this would be 0, and then this would be cancelled out. This will cancel out everything, and we have ln 2 over here. So this would be negative ln 2 dy by dx when x equals to 0. Negative ln 2, and then we have 0 plus 1 whole squared is 1 simply. So this will be negative ln 2. This is our tangent's gradient. For normal gradient, we have to take the inverse reciprocal. So this would be 1 over ln 2. So we have our gradient. Now let's use y minus y1 is equals to m x minus x1, right? We have our m, that is 1 over ln 2. We have our x1, which was 0. So let's skip it. And we have our y1 as ln 2, which we calculated over here. So this would be ln 2, right? Now, since it was written, it meets the x-axis at point B. So for point B, y is equals to 0. We can plug in y is equals to 0 over here. So we get negative ln 2 multiplied by ln 2 as our x. So basically it is ln 2 whole squared and negative as our x, right? So we have our x, right? Now point C has coordinates this. Find the gradient of the line BC in terms of ln 2. So we have our CS, we have our BS, negative ln2 whole squared, comma 0. We have our c as 0 comma 3 ln2. We can take the LCM. Sorry, we can take the gradient. So for gradient, we will be using y2 minus y1 and x2 minus x1. So this y2, 3 ln2 would be subtracted by 0. Let's just remove this. And then this would be 0 minus ln2 whole squared. So this would be positive ln2 whole squared. This will be cancelled out. So this would be 3 over ln2 as our gradient simply. So this is our final answer. Now moving on, we have our question 10, which is given the simultaneous equation lgx plus 2lgy is equals to x minus 3y square is equals to 13. We need to show that x square is minus 13x minus 30 equals to 0. Let's just solve this first. So this would be lg x lg y square and 1. We can use the product law over here. So this would be lg to make it a single log. So this would be lg xy square is equals to 1. We can remove this lg and then take this to the power of 10. So this would be 10 powered 1 and xy square. So we have our first equation, right? Now we have our second equation as x minus 3y square equals to 13. Now since we need to make x y square as the subject, since we need the x square term, so we need to make the y square as subject. So we have y square as 10 over x. This is our equation 3. This was our equation 2, right? So let's substitute this over here. So we have x minus 3 10 over x equals to 13. This is x minus 30 over x equals to 13. We can multiply the whole equation by x. So we get our answer as x squared minus 13x. This 13 would go over there. And then negative 30 equals to 0. So we get our final answer. Solve the simultaneous equation giving your answers in exact form. It needs an answer in exact form. So let's solve this first. So this would be x squared positive 2x. The factors would be positive 2x and negative 15x. So this would be negative 15x equals to 0. And then we can take it as x plus x into x plus 2, then negative 15, then x plus 2 equals to 0. We have our x as negative 2 and our x as 15. We have to reject this because this can't be here. lg negative 2 is not possible, right? So we have to take x equals to 15, right? Now we can plug in this x equals to 15 over here. So this would be y squared is equals to 10 over 15. We can cancel this out. So this would be 2 over 3. We have our y as plus minus root 2 over 3, right? So we have this solution. This is our x, this is our y, right? Now we have part B, solve the equation this, where a is the positive constant giving x in terms of a, right? So we have log ax. This can be written as reciprocal of log ax. So this would be 3 over log ax equals to 4. Now we can take log ax as simply y. We can assume this as y. So this would be log ax as y. We have taken log ax as y, right? So this would be y plus 3 over y equals to 4, right? We can multiply the whole equation by y. So this would be y squared minus 4y plus 3 equals to 0. We have our roots as negative 3 and negative 1. So this would be negative 1, negative 3 plus 3 equals to y is equals to 0. Taking y as common, we have y minus 1, negative 3 as common, y minus 1 equals to 0. So we have y as 1 and y as 3. So this would be log ax equals to 1 and log ax equals to 3. This means this a will go in the power, this a will have power 1 and this will be equal to x. So this will be x a and this would be x a cube. So we have the two answers, right? It had to be in terms of a, right? So we have the answer. Moving on to question 11. I hope it's the last one, I guess. In this question, all lengths are in kilometers and time is in hours. That's just understood. A particle P moves in a straight line such that its displacement s from a fixed point at time t is given by this. Find the values of t for which the velocity is 0. To calculate the velocity, we need to take the differentiation of displacement. So ds upon dt is basically velocity, right? So ds upon dt, for ds upon dt, we have to solve this first. And this would be t minus 5 whole squared is t squared. Negative 5 into 2 is 10t. Then this is 25. This is multiplied by t plus 2. So we get our answer as finally t cubed. This would be negative 10t, and then negative 10t square, and then this would be positive 2t squared. So this would be negative 8t squared, right? And this would be t would be 25t and negative 10t, 25t minus negative 20t. So this would be positive 5t, right? And this would be 25 into 2 is 50, right? So we can take the over here. So this would be 3t squared, then 16t, then plus 5. So we have this as our equation. We can take the LCM, I guess. This would be negative 16t. I'm sorry for the mistake. This would be negative 16t, right? We can solve this by equating it to 0, right? So this would be, we have to take the we have to use the middle term break method. So this would be 3t squared. We'll be having our what we can say, our roots as negative 15 and negative 1. So this would be negative t and negative 15t plus 5 equals to 0. So this would be 3. We can take t as common. So this would be 3t minus 1. We can take negative 5 as common. So this would be 3t negative 1 equals to 0. So we have t minus 5 and 3t minus 1 is equals to 0. So we have t as 5 and t as 1 over 3. So velocity is 0 when t is equals to 5. Velocity is equals to 0 when t is equals to 1 over 3. Right? On the axis, draw the displacement time graph for 0 till 6, stating the coordinates of the point where the graph meets the coordinate axis. So we need to first calculate where it basically is when t is equals to 0. Right? Let's write this equation over here. So this would be easier. This is t plus 2, I guess. Sorry. And then t minus 5 whole squared. We have to calculate t is equals to 0. So when t is equals to 0, this would be 2. And then minus 5 whole squared, this would be 25. And then this would be 50. So it will be starting from 50. Let's take a rough guess. So this would be 50. Right? And we have our velocity as 0 on 1 over 3. Let's assume this is 1 over 3. And let's take the value of s when t is equals to 1 over 3 and t is equals to 5. So 1 over 3 would be 1 over 3 plus 2. So this would be 7 over 3. Right, 7 over 3. And then 1 over 3 minus 5 would be minus 14 over 3. And this is whole squared. This is multiplied. So this would be a bit complex, but it has a value, right? So it has a positive value, right? So it will be somewhat around 50, but the gradient would be 0 over here. So let's just take this here, right? Now let's take t is equals to 5. T is equals to 5 would be, if you plug in t is equals to 5, so this would make it 0. Velocity would be 0 and displacement would be 0 again. So this would be 0 here. So we can draw our graph. So this would be so this would look something like this, and then this would again move upwards, right? So this will be our final graph. right? Now we have our part C. On the axis below, draw the velocity time graph. Now it needs a velocity time graph, right? So let's just take what we'll get when t is equals to 0 over here. We have our velocity equation over here. When t is equals to 0, we have negative 5, and this would be 0 and then negative 1. So this is 5. So when t is equals to 0, we have v as 5. So let's assume this is 5, right? Now it has to be 0 at 1 over 3. So this would be something like this, right? It has to be 0 at 5, right? So it needs to have somewhat a point where it has a minimum or maximum point. Let's take this and then differentiate it to get our minimum or maximum point, right? So when we differentiate it, we get it 60 negative 16 equals to 0. So this would be 16 over 6, and then t, we can use this as t, and this would be 8 over 3, which means this is 2.2 whole 2 upon 3. So this would be 2 whole 2 upon 3. So this would be 2.66 something. So we can assume this as here. This would be 2.67 over here. And let's just assume it like this. And then we can just make it like this. This goes up. So this is our velocity time graph roughly, right? Now moving on, we have D part 1. Write down an expression for the acceleration. We wrote it already. Here we wrote it, right? We have to just copy it down here. So this would be 60 minus 16, right? On part 2, hence on the axis below, draw the acceleration time graph for P when t is in between 0 till 6, stating the coordinates of the point where the graph meets the coordinate axis. So we need to make the acceleration graph. We have the equation 60 minus 16. Let's just use t is equals to 0 over here. So this would be negative 16. And when acceleration is 0, so we get it as 2.33, 2.66, sorry. We used it before. So this is 2.66. Let's assume this is negative 16. Let's use a scale and draw a line. So this is basically this, right? So this is our acceleration line. Acceleration is equal to 60 minus 16, right? So this is it, and I guess this is it from my side. Thank you for watching. Please do like, share and subscribe our channel. Thank you so much.